Carl Skinner is a name synonymous with firefighting and forest management in the United States. He began his career as a firefighter in Lassen County in 1968 and went on to become one of the most respected and accomplished scientists in his field. After an illustrious career spanning 42 years with the U.S. Forest Service, Carl retired in 2014, leaving behind a legacy that continues to inspire those who work in the field of fire science today. Carl Skinner's contributions to the field of fire science are numerous and far-reaching. He is particularly interested in the interplay between fire and climate, and his research in this area has helped to shape our understanding of how wildfires behave and how best to manage them. His work has been instrumental in the development of fire management strategies that are both effective and environmentally sustainable.
I'm Carl Skinner. I'm a retired research geographer. I worked with the U.S. Forest Service Experiment Station and was stationed in Redding, California. I actually worked for 42 years for the Forest Service, half of that in fire management and half in fire research. And I'm going to be talking today about risk versus hazard. A lot of people talk about risk. You hear it all the time. Everybody's talking about risk, but they don't talk about risk of what other than just fire, in a sense. And nobody talks very much about hazard, and hazard is what actually gives you the severe fires that people would like to avoid. And so I want to distinguish between the two. And one of the things I like to impress on people is how common fire used to be in California. And this is from John Liburg. He was one of the foresters who studied the forests in the Sierra Nevada and the Cascades and other parts of the West to determine which areas should become national forests and what would be national forests and so forth. And this is what he said after spending time in the Sierra Nevada and the Southern Cascades. He said the most potent factor in shaping the forests of the region has been and still is fire. The general character of the forest, in fact, almost every phase of its condition has been determined by fire, which is kind of interesting to think about because of the huge trees and the expansive forests that we had at that time, and yet there was evidence of fire everywhere, and that's what he was talking about. Another one of the people that did early surveys of the vegetation was C. Hart Merriam. He was chief of the Biological Survey for the United States at the time, and he spent time in Siskiyou County. And after being there for a couple of years, he said this. He says, of the hundreds of persons who visit the Pacific Slope in California every summer to see the mountains, few see more than the immediate foreground and a haze of smoke, which even the strongest glass cannot penetrate. That was pretty typical summers back then because of all the fires that would be burning. So why so many fires? It's because of our climate. We have what's called a Mediterranean climate, and it's located in only particular places in the world. It's usually on west coasts of continents and in particular latitudes. But they have certain characteristics that predispose them to fire. First of all, we have cool, wet winters that grow vegetation, lots of vegetation, and that's fuel. But Mediterranean climates are characterized by warm, dry summers. You have an annual drought every year. There's a fire season every year, regardless of how much rain you got in the wintertime. And we have occasional thunderstorms that no matter what people are doing, you're still going to have fires because Mother Nature provides for that. Here's where Mediterranean climates are found worldwide, and the reason they're called Mediterranean climates is because the largest area of this type of climate is around the Mediterranean basin, Mediterranean Ocean area. And in the last few years, we've heard of the fires in southern France and Spain and Portugal, and also in Greece and Lebanon and Italy. There's lots of fires been going on in that area. There's fires going on in central Chile right now that are pretty destructive fires from what I gather, and very extensive. There's South Africa has this type of climate, as well as Australia, and you remember a lot in the news about the fires of Australia. And you see the west coast of North America, we have from northern Baja into southern Oregon is Mediterranean climate zone, and which is no area known for fires and such. But what's interesting about that sliver of our area, our continent, is that's where 30% of the United States national wildland fire management funds are expended, is in there, because of the populations that are there as well as the predisposition to fire. Now, one thing I want to do is show you how these patterns that are associated with the Mediterranean climate predispose us differently than other parts of the country. And so this first area is North Platte, Nebraska. And if you look at these charts, it goes from January through December, and this is precipitation amounts and how the precipitation comes in. And what you see here is that the warm period of the year is the wet period of the year. This is typical of a lot of continental, especially mid-continental type areas, because of the thunderstorms they get in the summertime and such. This one's interesting. This is Yellowstone Lake in Wyoming. And if you look at the precipitation bars, you can't tell what month it is, basically, by the amount of precipitation. It just changes form. Goes from snow to rain and back to snow. But, and so they basically, in order to have major fire years, really have to have a drought. Here's Flagstaff, Arizona. And this is interesting because they have wet winters like we do, a dry spring, and then they have a wet summer. This is called, the southwestern monsoon is what this is. And as soon as it heats up in the southwest area, they get the moisture coming in off of the Gulf of California, the Gulf of Mexico, and so forth, and it comes in and they have lots of thunderstorms, and it usually shuts down fire season unless there's something unusual going on. But we often see this is where the fire season starts from year to year, is in West Texas, New Mexico, Arizona, and then it moves from there into other areas as they kind of shut down. Here's Redding, and you can see it's totally different than any of the others. And what it is that we have the cool season of the year is when we get the moisture, and the warm, dry season of the year is dry for that reason. It's the Mediterranean climate. We basically don't get much precipitation in that dry part of the year, and that's why we're set up for fires. And we do get a fair bit of lightning. This was from 1986 to 1996, this study that was done, and it basically shows red dots are lightning-caused fires and blue dots are human-caused fires. And basically where there's lots of humans, you see a lot of blue, but when you get into the mountainous areas, and especially when you get around where we are here in Shasta County area, you get a lot of both. Mixing in there from the thunderstorms that do come in the summer and also the population here. Okay, hazard versus risk. That's what I wanted to talk about. Hazard. Hazard is the fuel complex, which is defined by the kind, the arrangement, volume condition, and the location, how it's located in the landscape, that presents a threat and so forth, and resistance to control. The more there is, the harder it is to deal with. Risk. Risk is basically the chance of fire starting as determined by the presence and activity of causative agents like lightning or people doing things, and a fuel complex that can ignite. And so that's basically what risk is. And we have risk all the time. We have different hazards depending upon where you are. So hazard versus risk. This one kind of throws people when I first show it to them. This on the left, I say is a high hazard, but it's actually a low risk. And I'll talk to you why that is in the future. And then the one over on the right-hand side is a low hazard, but a high risk. And that's because of the nature of the fuels there. And I'll get to that in a bit, this difference between these places. Hazard. This is high hazard, high risk. This is in the McCloud Flats, is what you're looking at here, just east of Mount Shasta, and an area that is pretty overgrown and kind of trying to thin itself because of what's there. Here's another one. This is actually in the Hat Creek Valley, and this burned in the Dixie Fire. I don't have a picture of it since it burned, but I've been there since it burned, and it doesn't look like that anymore. And that's a high hazard, high risk. Another high hazard, high risk, this also is in the McCloud Flats. This is where the beetles had gone through and killed a bunch of trees, and this is around 8 years or so after the trees had been killed, and so now they're falling down and creating a heck of a fuel load on the ground that can burn severely when the fires come through. And then here's the one that's high hazard, low risk, and I'll give you a sense of why that is in just a moment, because it's definitely a high hazard. Look at all the fuel in there. Now, risk. This is a high risk because it's in the summers dries out, and it's actually next to a road, so it could easily have people toss something out on it, or could end up with lightning. Here's low hazard, high risk. There's low hazard because there's very little fuel in the underneath in here, and it's high risk because the nature of the fuel that's there is very flammable. It's very fine, like grasses and herbs and that kind of thing, but there's not much to really get a severe fire going. And this is actually in a wilderness area near, and it's called the Beaver Creek Pinery up out of Chico in the Ishii Wilderness. And the fires, 2 fires had gone through this area. One was a 30,000 acre fire, and the other one was a 60,000 acre fire within the 8 years before I took this picture. And then this is low hazard, high risk. High risk because look at all that dry grass. But there's not much there other than that to burn. So that's the reason for a low hazard. And then this one is low hazard and low risk. And the reason that this is almost a subalpine area up near Mount Eddy in the near China Mountain area. And the fuels on the ground are not even contiguous and so forth. There's a lot of bare space there, and there's not a lot of fuel that's collected because fuels grow slowly in this area because of the high elevation, and so it's just not a place that's conducive to severe fires. Now here's an area that's been thinned. They went in there and they thinned it, got rid of the big trees. There's no intervening touching of the crowns and so forth, but look at the ground. Look at all of the fuel that's left. No work was done appreciably to reduce the fuels on the surface. And then this one was thinned, followed by a prescribed fire to clean up the stuff on the ground. And so it looks like this. And here's how they burned. Because this is in our Blacks Mountain Experimental Forest just north of Lassen Park. And a wildfire did come through there in 2002, driven by a north wind, 6% humidity. And I mean, it was, it was severe, potentially. That's what that one ended up looking like, because the fire went through there with all that fuel on the ground, and even though it wasn't a crown fire from crown to crown, it still killed almost all the trees. And there was just so much fuel down there and heat. Where the other one ended up looking like that after the fire. So, our fires in the past were frequent, but generally in a lot of the California forests of low intensity, and they created and maintained forests like this. We decided we knew better than Mother Nature, and so we started putting fires out and created forests that look like that. Over, almost a century now, and these are characteristic of places like in the Rockies and places that don't have frequent fires but when they burn intensely. Places that look like this have a tendency to carry fires that look like that. And places that look like this have fires that move from the ground up into the crowns through the ladders. Now here's an example. This is from that fire that I was telling you about at the Blacks Mountain Experimental Forest, the cone fire. And the fire started up in this area and driven by the north winds came straight at it. This is the boundary of the experimental forest right here. And this side is the experimental forest and this is outside of it. And so what you see is these were unthinned areas. They had not had fuels treatments. They were completely, and they were not thinned. This area had been thinned and followed by a prescribed fire. And then down here, this area had been thinned in the early 1980s, and so a lot of the fuels that were left had rotted by now anyway. And so there, you can still see that there is some green in there, but it takes a while to get to that point. What I did was right here, I went to the edge of the unit and stood on the boundary, took a picture looking at where the fire came from, and then just turned around and didn't move anywhere else, just turned around 180 degrees and took a picture of what the forest on the other side of that boundary looked like. And this is what they look like. You get this one, which is the side where it was unthinned and where the fire came from. It's, there's nothing out there now that wasn't burned by that fire. And then I just turned around, took that picture. That's how fast it changed. And that's what's actually important for even people thinking about what to do with say, small properties and so forth, is what can happen regardless of what else happens in the landscape. Here's another one, thinned and prescribed burned. And then when the fire went through, it ended up like that. And that's what Mother Nature used to prescribe for. And this is one of the reasons we were doing this study, was to look at the effects of managing forests in different ways in regards to fire hazard. Now this is what a forest up in the Hatchet Mountain area looked like in the 1920s. This is a soil veg survey photo. And then by the 1980s, it had turned into this. Most of the big trees had been logged out and the smaller trees had grown in, and lots of them. And so it ended up looking like that. And then in 1992, we had the fountain fire that burned through there. And it did quite a number on the area. It burned 45,000 acres in one afternoon as it was coming over the pass here. And then 2 years later, I took this photo from as close to the same place as the one in 1982 as I could find. It was kind of hard to tell where it was after all that. I had no idea you could even see Mount Shasta from there before. And but you can see what it did to that landscape. And so that's what changing that environment ended up doing. So risk and hazard. Risk, the probability or chance of having a fire. And in California, there's always some kind of risk. And so if you have any vegetation at all. Hazard is the type of fire or the intensity of the fire, what it will likely burn like. And it's the hazard that we can work with the most. Okay, which stand to treat? I'm back to these two. And what's important is the landscape context. Where they are in the landscape. Place matters. This one is here. There's a lake on 3 sides of it, and on the other side is almost barren slopes that can't burn anyway. And so even the only way it's going to burn is if lightning hits it right there, or some camper in the area manages to do something they shouldn't do. And this is in the Castle Crags Wilderness, by the way. And so that is not really a high priority place to mess with. This one, on the other hand, is in the Beaver Creek Pinery on a ridge top up here between two major watersheds, Deer Creek and the Mill Creek area up out of Chico, which are major anadromous fisheries too and such. And so this one to me is the one that is most important to focus on from a management perspective and to try to maintain it in the kind of condition that it's in and not let it go the way of a lot of other places. Thank you.